Hi everyone, welcome back to our YouTube channel. This video will cover week 3 of quarter 4. MELC number 33 proves inequalities in a triangle. And after going through this lesson, the students are expected to recall concepts learned regarding basic geometry, recall theorems on triangle inequalities, apply theorems on proving triangle inequalities. Just a quick recap, we have 6 theorems on triangle inequality. First, the relationship of side and its opposite angle. Second, relationship of the angle and its opposite side. Third, the relationship of the sides of a triangle, wherein side 1 plus side 2 is greater than side 3. Fourth, exterior angle inequality theorem. Fifth, Hinge theorem. And sixth, converse of Hinge theorem, wherein Hinge theorem and converse of Hinge theorems are inequality in two triangles. Now let's talk about triangle inequality theorem 1, or the relationship of side and its opposite angle. If one side of a triangle is longer than a second side, then the angle opposite the first side is larger than the angle opposite the second side. Let's take an example. Given triangle SET is an isosceles. Line segment ST is greater than line segment SE. Line segment ST is equal to 15 and line segment SE is equal to 11. Prove that measure of angle SET is greater than measure of angle STE. So again, to prove this, we need to use the two-column proof. And based on our given information, what is our first statement? And what do we mean by isosceles? Alright, when we say isosceles triangle, a triangle with two equal sides. And observe our illustration. We have markings here, right? So our first statement, line segment SE is congruent to line segment TE. The reason is definition of isosceles triangle. And what is the second statement? Alright, we have another two given information here. So for our next statement, line segment ST is equal to 15 and line segment SE is equal to 11. The reason is given. Next, line segment ST is greater than line segment SE. The reason is given. And since we have all the information here to prove this statement, so for our last statement, measure of angle SET is greater than measure of angle SET. The reason is side angle inequality theorem. Alright? Second example, given triangle CAN. AN is greater than AC. Prove that measure of angle CAN is greater than measure of angle CNA. Proof: there is a need to make additional constructions to prove that measure of angle CAN is greater than measure of angle CNA. With a compass point on C and with the radius CA, mark a point S on CN and connect A and S with a segment to form a triangle. Again, in this given example, we need to prove that measure of angle CAN is greater than measure of angle CNA. Observe the given illustration. Alright, for our first statement, how do you describe the relationship between CA and CS? We have markings here. So, CA is congruent to CS. The reason is by construction. For our second statement, based on statement number 1, what kind of a triangle is triangle CAS? Since CA and CS are congruent. Okay, this triangle is an isosceles triangle, and the reason is definition of isosceles triangle. Statement number 3, based on statement number 1, how do you describe angle 1 and angle 2? Angle 1 is congruent to angle 2. The reason is base angles of isosceles triangle are congruent. For our fourth statement, study the illustration and write a statement about angle CAN if the reason is one of the given. So as you can see in our illustration, angle CAN consists of two angles. So angle CAN is equal to angle 1 plus angle 3. The reason is angle addition fashion. Next, based on the statement number 4, write an inequality statement focusing on angle 1. So angle CAN is greater than angle 1. The reason is property of inequality. Next, using statement number 3 and statement number 5, measure of angle CAN is greater than measure of angle 2. So, angle CAN is greater than angle 2. The reason is substitution property. For our seventh statement, study the illustration and write an operation statement involving angle ASN, angle N, and angle 3. These three interior angles. Alright, angle ASN plus angle N plus angle 3 is equal to 180 degrees. The reason is the sum of the measures of the interior angles of a triangle is 180 degrees. Next statement, study the illustration and write an operation statement involving angle 2 and angle ASN. So these two angles. As you can see here, these two angles are next to each other. Alright, angle 2 and angle ASN is equal to 180 degrees. So the reason is linear pair theorem. Always remember, the angles are said to be linear if they are adjacent to each other or next to each other. And the sum of the angles is always equal to 180 degrees. Alright? So based on statement number 7 and 8, measure of angle 2 plus measure of angle ASN is equal to measure of angle ASN plus measure of angle N plus measure of angle 3. So the reason is what property supports the step wherein we replace the right side of statement number 8 with its equivalent in statement number 7. Alright, so this property is transitive or substitution. Next statement, what will be the result if measure of angle ASN is subtracted from both sides of statement number 9? Alright, angle 2 is equal to angle N plus angle 3. What will be the reason? The reason is subtraction property. Next, based on statement number 10, write an inequality statement focusing on angle N. So we have angle 2 is greater than angle N. The reason is property of inequality. Next statement, based on the statements number 6 and 11, if measure of angle CAN is greater than measure of angle 2 and measure of angle 2 is greater than measure of angle N, then angle CAN is greater than angle N. The reason is transitive property. Next, triangle inequality theorem number 2. This is the relationship of the angle and its opposite side. If one angle of a triangle is larger than a second angle, then the side opposite the first angle is longer than the side opposite the second angle. Example, given triangle SPN, measure of angle U is greater than measure of angle S. Proof that SN is greater than UN. So use the indirect proof. Assume that SN is not greater than UN. To prove this, let's use the two-column proof and let's fill the information. For our first statement, Sn is congruent to Un or Sn is less than Un. So the reason is this is just an assumption that Sn is not greater than Un. Alright? So for our second statement, considering Sn is congruent to Un. So if Sn is congruent to Un, then we have two equal sides. Then triangle SUN is an isosceles triangle. So if you have this statement, the reason is definition of isosceles triangle. Alright? So consequently, what can you say about angle U, this angle, and angle S? Alright, angle U is congruent to angle S. The reason is base angles of isosceles triangles are congruent. The assumption that Sn is greater than Un is true or false? Alright, false. And the conclusion that measure of angle U is congruent to measure of angle S, alright, contradicts the given that measure of angle U is greater than measure of angle S. Now, for statement number 3, considering Sn is less than Un, if Sn is less than Un, then alright, angle U is less than angle S. The reason is triangle inequality theorem number 1. Next, the assumption that Sn is less than Un is true or false? Alright, false. And the reason, the conclusion that measure of angle U is less than measure of angle S contradicts the given that measure of angle U is greater than measure of angle S. So therefore, Sn is greater than Un must be true or false? Alright, true. And for the reason, the assumption that Sn is greater than or not greater than Un contradicts the known facts that measure of angle U is greater than measure of angle S. You can pause this video for you to easily read all the information. Now let's talk about triangle inequality theorem number 3. Or this is the relationship of the sides of the triangle. So the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Example, given triangle LMN where LN is greater than LM but less than MN. Prove that MN plus LN is greater than LM. MN plus LM is greater than LN, and LM plus LN is greater than MN. Proof, notice that since Mn is greater than Ln and that Mn is greater than Lm, then it's obvious that Mn plus Lm is greater than Ln. And Mn plus Ln is greater than Lm are true. Hence, what remains to be proved is the third statement, Lm plus Ln is greater than Mn. So let us construct line segment LP as an extension of Lm, such that L is between M and P. So line segment LP is congruent to line segment Ln, and triangle LNP is formed. Now given triangle LMN where Ln is greater than Lm but less than Mn. Prove that Lm plus Ln is greater than Mn. So here is the two-column proof, and let's fill the information. First, write a statement to describe LP and Ln. So here, LP and Ln. Observe the illustration and the markings. Alright, line segment LP is congruent to line segment Ln, and the reason is by construction. Second, describe triangle LNP. So this triangle. Alright, triangle LNP is an isosceles triangle. And the reason is definition of isosceles triangle. Now, describe angle LNP, this angle, and angle LPN, this angle. Okay, this two angle or angle LNP is congruent to angle LPN. The reason is base angles of isosceles triangle are congruent. Fourth statement, the illustration shows that angle LPN, this angle, is congruent to angle MPN, this angle. So the reason is reflexive property of equality. And if angle LPN is congruent to angle LPN, which is statement number 3, and angle LPN is congruent to angle MPN, which is statement number 4, then angle LNP is congruent to angle MPN. So the reason is transitive property of equality. For our sixth statement, from the illustration, angle MNP, this angle, is equal to angle LNM plus angle LNP, these two angles. The reason is addition or angle addition postulate. Alright? And using statement number 5 and statement number 6, measure of angle MNP is equal to measure of angle LNM plus measure of angle MPN. And the reason is substitution property. And from statement number 7, we can say that angle MNP is greater than angle MPN. And the reason is property of inequality. And using statement number 8 and the illustration, write a statement with the reason given. Alright, MP is greater than MN. And the reason is triangle inequality theorem number 2. From the illustration, what operation involving LM and LP can you write? Alright, LM plus LP is equal to MP. So that is segment addition postulate. For statement number 11, write a statement using statement number 10 and statement number 9. Alright, LM plus LP is greater than MN. So the reason is substitution property of inequality. Next, write a statement using statement number 1 and statement number 11. So Lm plus Ln is greater than Mn. So that is substitution property of inequality. You can pause this video to see all the information. Next, exterior angle inequality theorem. The measure of an exterior angle of a triangle is greater than the measure of either remote interior angle. Example, given the figure, prove that measure of angle BCE, or this angle, is greater than measure of angle DBA, or this angle. Again, let's use two-column proof here. For our first statement, measure of angle BCE is greater than measure of angle CDB. So what is the reason? Alright, definition of exterior angle inequality theorem. Next, what is the second statement? With the recent definition of exterior angle inequality theorem. Alright, angle CDB is greater than DBA. Again, the reason is definition of exterior angle inequality theorem. So for our third statement, based on our first statement and second statement, we can now prove that measure of angle BCE is greater than measure of angle DBA. The reason is transitive property. Next example, given triangle LIO with exterior angle LOV. Prove that measure of angle LOV is greater than measure of angle LIO. Proof. Let us prove that measure of angle LOV is greater than measure of angle ILO by constructing the following. First, midpoint E on LO such that LE is congruent to OE. Second, IU through E such that IE is congruent to EU. Now let's prove measure of angle LOV is greater than measure of angle ILO using the two-column proof. First statement, LE is congruent to OE and IE is congruent to EU. What is the reason? By construction. Alright, number 2, what relationship exists between angle 3 and angle 4? As you can see here, two lines intersect and forms vertical angle. Alright, angle 3 is congruent to angle 4. The reason is vertical angles theorem. Third, based on statements 1 and 2, relate two triangles from the illustration. These two triangles. Alright, triangle LEI and triangle OEU are congruent. Alright? And what triangle congruence postulates supports statement number 3? SAS triangle congruence postulate. Statement number 4. Basing on statement number 3, angle ILO is congruent to angle 1. The reason is corresponding parts of congruent triangles are congruent, or CPCTC. Statement number 5, basing on illustration, angle LOV, or this angle, is equal to angle 1 plus angle 2. The reason is angle addition postulate. Statement 6, basing on statement 5, measure of angle LOV is greater than measure of angle 1. The reason is property of inequality. And 7, using statement 4 and statement 6, angle LOV is congruent to angle ILO. So that is substitution property of equality. Alright, you can pause this video to see all the information. Inequalities in two triangles. Hinge theorem. If two sides of one triangle are congruent to two sides of another triangle, but the included angle of the first triangle is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. Let's take an example. Given line segment AF is equal to line segment MR. Measure of angle ARF is greater than measure of angle ARM. Let's prove that line segment AF is greater than line segment AM. So I have here two column proof. Our first statement based on our given information is AF is equal to MR. The reason is given. Second, we have here another information. So measure of angle ARF is greater than measure of angle ARM. The reason is given. Next, observe the given illustration. As you can see here, we have a common side. So for our third statement, AR is equal to AR. The reason is reflexive property. Since we have all the information needed in this example, we can prove that line segment AF is greater than line segment AM. So the reason is Hinge theorem. Next example, given line segment AB is congruent to line segment BE. Line segment BC is congruent to line segment BF. And measure of angle B is greater than measure of angle E. Proof that AC is greater than BF. Construct BM such that BM is congruent to BC and congruent to EF. BM is between BA and BC, and angle ABM is congruent to angle DEF. Note, consequently, triangle BAM is congruent to triangle DEF by SAS triangle congruence postulate. So AM is congruent to BF because corresponding parts of congruent triangles are congruent. Second, construct the bisector VH of angle CBM. H is on AC and angle CBH is congruent to angle MBH. Note, consequently, triangle CBH is congruent to triangle MBC by SAS triangle congruence postulate because BH is congruent to BH by reflexive property of equality. And BM is congruent to BC from construction number 1. So MH is congruent to HC because corresponding parts of congruent triangles are congruent. Now let's prove AC is greater than BM. For our first statement from the given illustration, AC, this segment, is equal to AH plus HC. So what will be the reason? That is segment addition postulate. How about the statement number 2? Alright, AC is equal to AH plus MH. So what will be the reason? That is substitution property of equality. So in this given triangle AHM, we know that AH plus MH is greater than AM. And the reason is triangle inequality theorem number 3. So using these two statements, statement number 2 and statement number 3, we can say that AC is greater than AM. The reason is substitution property of equality using statement 2 and 3. So using statement in construction number 1 and statement number 4, we can prove that AC is greater than BF. The reason is substitution property of equality using statement in construction 1 in statement number 4. Converse of Hinge theorem. If two sides of a triangle are congruent to two sides of another triangle, but the third side of the first triangle is longer than the third side of the second, then the included angle of the first triangle is larger than the included angle of the second. Given triangle ODG and triangle LUV, OD is congruent to LU and DG is congruent to UV. Line segment OG is greater than line segment LV. Proof that angle D is greater than angle U. So given the first reason, what will be our first statement? So the reason is assumption that measure of angle D is not greater than measure of angle U. So that will be angle D is congruent to angle U, or angle D is less than angle U. Okay, second statement, consider angle D as congruent to angle U. It's given that OD is congruent to LU, DG is congruent to UV. If angle D is congruent to angle U, then triangle OG is congruent to triangle LUV. So what will be the reason? That is SAS triangle congruence postulate. How about the statement number 3 with the reason of CPCTC or corresponding chords of congruent triangles are congruent? Alright, so from the congruence, OG is congruent to LV. Right? So the assumption that angle D is congruent to angle U is false. The reason is OG is congruent to LV, contradicts the given that OG is greater than LV. Next statement, consider angle D is less than angle U. If angle D is less than angle U, then OG is less than LV. What is the reason? The reason is Hinge theorem. And the assumption that angle D is less than angle U is false. What will be the reason? OG is less than LV, contradicts the given that OG is greater than LV. And therefore, angle D is greater than LU must be true. Assumption that measure of angle D is not greater than measure of angle U is proven to be false. That's all for today. Thank you so much, grade 8 students.